So in this video, we will be writing a script to perform breast cancer diagnosis using K nearest neighbors algorithm. So this is on the Wisconsin Diagnostic Breast Cancer Dataset, which is taken from the UCI machine learning repository. So in the first step, we will be importing some libraries, some necessary libraries, which includes pandas, sklearn, and yeah, these two. We'll be having the pandas for data manipulation and analysis. Example like creating data frames. And the sklearn, we import train, test, and split. We use it to split the dataset into training and testing sets. So after this, the standard scalar label encoder. This is for feature scaling and encoding categorical labels. We'll have this K-neighbors classifier from scalar.neighbors, which is the KNN classifier model. And from the scalar metrics, we'll have accuracy score. This is for evaluating model performance. And after this, we will start the main function to load data, train, and evaluate the KNN model. In this, we'll be loading the dataset. The dataset was loaded directly from the UCI data repository. It does not have a header, so we define columns manually, and the URL pointing to the raw dataset file is this one. Okay, and these are the names that I have written already, column names. And after this, we'll be using pandas to read the CSV data from the URL, and we'll be assigning specified column names. In the second step, we'll be doing the data pre-processing, which is first we'll be dropping the ID column as it's a unique identifier and not a predictive feature. Here we'll be giving the axis equal to 1. This specifies that dropping a column, and that is ID comma axis equal to 1. And after this, we'll be going to the encoding here, and here encoding the data diagnosis column, which is categorical to numerical. Here the malignant will be mapped to 1 and the benign will be mapped to 0. So after this, we'll be separating the features like we'll be separating the features and the target variables. Uh, X is for features except for diagnosis, and the Y contains only the diagnosis column. And after this, the third step includes splitting and training and testing the data, which is splitting the data into training and testing sets. We'll use 80% of the data for training and 20% for testing. Here random state 42 ensures that split is the same every time the code is run for reproducibility. Next, the fourth step includes feature scaling. Here, KNN is a distance-based algorithm, so scaling features is crucial to ensure all features contribute equally to the distance calculation. Here, features with larger edges would otherwise dominate the distance metric. So first, we'll be creating an instance of standard scalar, and then we'll be fitting the scalar in the training data to learn the mean and standard deviation. Then we'll be transforming it here, which is this one. So after this, you'll use the same scalar already fitted on the training data to transform the same data. So after transforming, we'll be moving on to the KNN, that is training the KNN model. We'll start with K equal to 5. A common choice for n beginners and neighbors. This means each prediction will be based on the 5 nearest neighbors. Create an instance of the K neighbor classifier with 5 neighbors. Next, we'll be training the model using the scale training features and their corresponding labels, which is after this. Okay, this one. And to this, the sixth step includes making predictions on the entire test set to evaluate accuracy. We're using the trained model to make predictions on the scale test data and evaluating the model's overall accuracy is seventh one, that is accuracy score, which is given like this. And after this, we'll be printing the model performance and the overall accuracy. The eighth step, which we are doing, is a testing of the test set. So we'll be predicting on a single sample patient from the test set. This section demonstrates how to use the model on a single case, which is given here. We'll be giving the values, that is sample patient data, and next the actual diagnosis for this patient to compare our prediction will be here. Sample patient. Then we'll be making a prediction for this single patient and we'll printing the result in a user-friendly manner. So that is given in here. To show the actual diagnosis, I mean, to compare the result and the actual diagnosis, I've given some the actual result in here. Okay, sorry, it's something. This, yeah, let's see. So after this is a standard Python construct. The code inside this block will only run when the script is executed directly, not when imported as a module. So we'll be calling the main function to run the entire process in here. So that was the code for the Wisconsin breast cancer diagnosis using KNN algorithm. We have the output here, the model performance. We have the overall performance as 0.9474, that is 94%. And as a result, we have here the model predicts the patient has a benign tumor, that is no cancer. For reference, as we have collected the reference data, that is, where is, yeah, this one sample prediction. This is the data. Yeah, here, the actual result, which we got. Yeah, see the for reference, the actual diagnosis for the sample was benign. And our model predicted the patient has, well, that is the accuracy. So that's it. That was the code.